We are looking at chapter 16, probability of class 11th. So what exactly this probability is, we have already seen in the earlier classes. That probability is, if you go to a bus station at 12 o'clock midnight, then the probability of getting buses are less. If you go at 12 noon, probability of getting buses are quite higher. We have seen in the earlier discussions that if you throw a dice is like a cube with some 1 to 6 numbers all around. So if you throw this die and say the probability of getting even number, so what it will be 3 by 6. What number can come? 1, 2, 3, 4, 5 and 6. So these are the 6 possibilities. These are, we call as the number of outcomes. These are number of outcomes. And what are these even numbers? 2, 4, 6. These are our favorable outcomes. So the ratio of the favorable outcomes to the number of outcomes possible is termed as the probability. We have already seen, and we call it as the classical theory of probability. If you intend to find out the odd numbers, then also the probability remains the same. This is the classical theory of probability, and in the earlier process we have seen the probability based on the observation and the data which is being collected. So this kind of probability is known as, or this approach of finding the probability using the data, inherent data properties, this is known as the statistical approach of probability. And both these theories have some or the other situation, or you can say the difficulties, and we will talk about those difficulties and try to solve them depending upon the activities and experiments. So we'll present some words. We'll define the probability as discussed by the great A.N. Kolmogorov, and he was a Russian mathematician, and he had a book called Foundation of Probability. So exactly we are going to see here axiomatic approach of probability here, and we will present the terms and discuss the terms in detail, like the random experiment, the sample space, events, etc. So let us start with the random experiment. What are random experiments? Random experiment is, if you have a triangle, you say that one thing is true, that the sum of the angle of triangle is 180 degree. This is true, okay? But what angle this is, you are not aware. It can be anything. If you toss a coin, anything can turn up. It can be head, it can be tail. So you are actually unsure of the angle and unsure of, you cannot predict whether it will be head or tail. So these kind of experiments where you cannot in advance know or predict the outcome is known as the random experiment. So there are two main conditions which any experiment has to satisfy to call it as the random experiment. First is it should outcome, or it should have more than one, means one plus outcome. One will not suffice, it has to be more than one possible outcome. The condition is, if you are able to predict the outcome in advance, then it will not be called as random experiment. So it has to have the possibility of not predicting the outcome in the advance. Let us find out whether tossing a die is random or not. It is actually a random experiment. So outcomes and sample space, we have seen the random experiment now. The result, any result can come. So the possible result of the random experiment, we call it as a outcome. So just consider the experiment of, say, you have a die, you want to roll the die. The outcome of this experiment can be 1 to 6. Okay, there are dots along the faces, and there are 1 dot to 6 dots. So the possible outcomes are what? 1, 2, 3, 4, 5, 6. This is the all possible outcomes it can be. So this is the sample space. This is the sample space of the experiment. We call it as a rolling a die. So this is represented by S. And all the element you see from 1, 2, 3, 4, 5, 6, these are called the sample points. So the outcome of any random experiment, we call it as a sample point. Take some example. You have 2 coins, say 1 rupee coin and a 2 rupee coin. They are tossed at once. And these are distinguishable because 1 rupee coin is quite different from 2 rupee coin. When we throw them or toss them, head may come here, head may come here. Tail may come here, head may come here. Head may come here, tail may come here. Or both may have. So the possibilities are heads on both the coin edge, head on the first coin and tail on the other coin, that is HT. Tail on the first coin and head on the other coin, that is TH. And tail on both the coins, that is TT. So just combine all these 4 and you get the sample space. So the outcome of this very experiment, these are actually the ordered pairs of HLT. And just for the sake of simplicity, we have just ignored the comma. Actually this combination or this set is the sample space. One more example we take. We want to find out the sample space which is associated with the experiment of rolling a pair of die. One is your blue, the other is red. So what can happen? Say we rolled a die blue, 1 can come. We rolled another die which is red, so it can be 1, it can be 2, it can be up to 6. So 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. These are all combination. Now in the experiment can be, the first one can be 2, so the other can be 2, 1, 2 2, 2 3, like 2 6. So these are all the combinations. So how many are there? First die has 6 outcomes, the other also has 6 outcomes, so 6 is 36. There is in all 36 outcomes. So we write like this. This is the sample space, and if you want to write in the term of you can have a set builder form and a roster form. So this is the set builder form, x comma y. So this you will get as the ordered pair, where x is the number of the blue die and y is the number of the red die. So the number of element of this space is exactly 36 now. So this is your sample space. By now you are aware how to create a sample space. What exactly is sample space? It is actually a universal set for all other set to follow. Let us take a few more examples. Say a boy has 1 rupee coin and a 2 rupee coin and a 5 rupee coin in his pocket. So this is a pocket. He has 1 rupee coin, 2 rupee coin and 5 rupee coin. So he takes out 2 coins out of his pocket. So when he takes this one, we call it as, say, Q. 2 we call it as H, and the third one is R. So if we take 1, the other can be 2, the other can be 5. If we take 2, the other can be 1, the other can be 5. So if we take Q, the other can be H or R. So one combination is QH and the other is QR. If the H is taken, the other can be Q, the other can be R. So HR, HQ. Okay, HR, HQ. These are 2 combinations. Then other can be, if it is R, then it can be, other can be H or R, H or Q. So RH, RQ. So the combination is QR, QH, HQ, HR, RH and RQ. The next is, there is a person who is noting down the number of accidents along a busy highway during a year. So he is sitting. It is possible that on a certain day no accident occurs. It may possible it may be possible that one accident has taken place, two, maybe 10, 100. So there is no counting. So the sample space has to be like this: 0, 1, 2, and dot 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 dot. These are the points showing it can go up to infinity. Next question is, a coin is tossed. If it shows head, we draw a ball from bag consisting of 3 blue and white balls. So you have a coin. If it is tossed, then you pick up from 3 blue and 4 white balls. Then if it shows tail, if it is head, then you do it. If it is tail, then what you do, you roll a die. So you can have a combination of 1 to 6. So HB1, HB2, HB3, then HB this W1, HW2, HW3, HW4, then T1 to 6. Okay, this can be possible. So if it is head, it can combine with ball 1 can be picked up, ball 2 can be picked up, ball 3 can be picked up, and in the similar fashion, head can be combined with 4 white balls. But if the outcome is tail, then it can be combined with, say, 1, 2, because this is the die. Die can give you a result as 1, 2, 6. So this is how we are going to present the result. Next question is, just consider the experiment in which a coin is tossed repeatedly until a head comes up. So first time it may happen that very first time head comes, then it is okay. It may happen that first time tail comes, then head comes. Then it may happen twice tail comes, then head. Then you can have thrice tail, then head. So it can go along, it can go up to, there is no limit. So H, TH, but remember all the ending values are H. So you will give as dot dot dot. So it is an infinite list. So we talked about the introduction of probability axiomatic, and we'll see more about these various words, important words which you are going to use now and in your later classes and your knowledge or education. So we'll see that. Thank you so much. Take care of yourself.